Hello everyone, you're on the Den Electro channel. Today I'll be talking about small converters for homemade power banks. The converter board has two connectors. The USB port is used to charge phones and other gadgets. The micro USB port charges the power bank itself. The board has a few components. The SM5401 converter and its small circuit board. A couple of capacitors, one resistor, one LED, and a coil. A simple power bank only requires one battery. In this case, I'll be using a small 18,650 battery. The positive and negative terminals coming from the battery should be connected to the same terminals on the converter. I connect the cable to the phone, and charging begins immediately. The red LED on the converter board lights up. Now let's look at the converter specifications. In this circuit, I connected a power supply instead of a battery. I'll be supplying 4 volts from it. This multimeter shows the current consumed by the converter. And the second multimeter shows the output voltage from the converter. The output is now 3.8 volts. This means that in idle mode, the converter currently consumes only 16 microamps, or 0.016 milliamps. This is a very small current, so the connected battery will discharge for a very long time in this state. When a phone or other load is connected to the converter's output, the voltage at its output rises to 5 volts. The connected light bulb now draws a small amount of current from the converter, and the converter itself draws 25 milliamps from the power supply. If the load is removed, the voltage drops again. Now let's look at the maximum current the converter can supply while charging the phone. And immediately increasing the load will measure its efficiency. I'll also supply 4 volts from this power supply. This tester will again display current, and this one will display voltage. I've already connected the electronic load, so the converter always displays 5 volts at the output. But the load is very small now, so the light on the board isn't lit yet. I gradually increase the load. The voltage has dropped, the current increased, and the indicator light on the board lit up. With a load current of half an amp, the voltage dropped to approximately 4.8 volts. That's approximately 2.4 watts. And the power supply, which acts as a battery, draws 700 milliamps at 4 volts. That's 2.8 watts. Recalculating all this, we get an efficiency of approximately 85%, a pretty good result. I'll increase the load even more. Now the power supply draws 5.12 watts, and the load draws about 4 watts. Efficiency 79%. If I increase the load further, the voltage drops to 4.3 volts at a charging current of 1 amp. Even though the voltage is low, the phone will still charge. At this point, almost 1.5 amps are drawn from the pseudo battery. The efficiency of the converter drops to 76%. If I increase the charging current even more, the protection circuit is triggered and the converter shuts down. It turns out that this converter delivers a maximum current of about 1 amp to charge the phone. To restore the converter to life, you need to disconnect the load. After this, the voltage at the converter's output rises again, and it's ready to use. Now let's see how much the battery discharges while charging the phone. The two testers on the right show the current and voltage going into the load. I gradually reduce the voltage on the power supply. When it dropped to 3.2 volts, the red light on the board started blinking. After the voltage dropped to 2.8 volts, the converter shut off. The voltage to which the batteries are charged is 4.17 volts. This is a normal voltage for this type of battery. And when the converter is in charging mode, the initial battery charging current is 0.9 amps. With this board and two batteries, you can make a simple power bank like this in half an hour. That's all for today. Like, subscribe to my channel if you haven't already, and bye everyone.